Now, we want to find the eigenvalues and the eigenvectors of 2, 0, 0, 2. Let's try this one. As usual, the matrix times this eigenvector is equal to the value of the matrix, the eigenvalue times the eigenvector. So you replace the matrix with its eigenvector, and it does the same thing. Now, of course, as usual, you subtract lambda x from both sides, that equals 0, and you factorize. So you have a minus lambda equals 0. But this cannot stand because a is a matrix and lambda is a single number. You need to subtract matrix from matrix. So you multiply this by I. I was going to put the I in brackets, but that wouldn't be necessary. Alright, so a minus lambda I. The determinant is 0. So let's see how this goes. A is 2, 0, 0, 2 minus lambda times I, which is 1, 0, 0, 1, is equal to 0. The determinant is 0. So we work this out. It's 2, 0, 0, 2 minus lambda 0, 0, lambda. Alright? The determinant is 0. Now, we have 2 minus lambda, 0 minus 0, 0 minus 0, 2 minus lambda. The determinant is equal to 0. Now, determinant is 2 minus lambda times 2 minus lambda minus 0 times 0, which is 0, equals 0. Multiply out the brackets. 2 times 2 is 2 squared, minus 2 lambda is negative 4 lambda, plus lambda squared is equal to 0. So what we have is lambda squared minus 4 lambda plus 4 is equal to 0. Now, if we solve this, we will get lambda. How can we solve this? Can we use factorization? Let's see. AC method, 1 times 4. We should find two numbers that multiply to give you 4, and they add to give you negative 4. Let's see. 2 and 2, they multiply to give you 4, but they don't add to give negative 4. What about negative 2 and negative 2? We could have worked it out from up here. It was factorized already. Alright? But we had worked it out. But we expanded it a bit too early. But anyway, if we should use the AC method on it, we should get back 2 minus lambda, 2 minus lambda. Because we would have lambda squared minus 2 lambda plus 4 equals 0. So lambda outside the bracket, lambda minus 2 times lambda minus 2 equals 0. So in this case, we would have lambda minus 2 times lambda minus 2 equals 0. Now if you multiply this by negative 1 and this by negative 1, we'll be saying times negative 1 times negative 1 is the same as multiplying everything by positive 1. This would be positive 2, negative lambda, positive 2, negative lambda equals 0. So you see it's the same thing as this. It's just that I had multiplied it out, then realized that it would be easier if I had just said 2 minus lambda all squared equals 0. But anyway, here, if you do that, 2 minus lambda squared equals 0. Same thing as lambda minus 2 squared equals 0. When you square root both sides, you're going to get 2 minus lambda equals 0. So 2 is equal to lambda. Or if you had said lambda minus 2 equals 0, then lambda would be equal to 2, right? So lambda is 2. The eigenvalue is 2. But anyway, what happens? What happens when lambda is 2? We want the eigenvectors. Now, a minus lambda I times x is 0. So let's rewrite it here. A minus lambda I times x is equal to 0. But what is a minus lambda I? It's this. It was 2002 minus lambda times 1001. And we worked it out to this. So 2 minus lambda 0, 0, 2 minus lambda. 2 minus lambda 0, 0, 2 minus lambda times x, which is our vector, we call it xy. You might use x1 and x2 if you want, alright? But I like using xy and xyz. But that is equal to 0, 0. It's equivalent to 0, alright? So what do we have here? 2 minus lambda x. Oh, by the way, lambda is what? What was lambda again? It was 2. So what we had is 2 minus lambda, which is 2 minus 2. That will amount to 0. So it's 0, 0, 0, and 0 here again. X, y is equal to 0, 0. So it is saying 0x times 0y is equal to 0. Now, you can say that x is the same as y. But you don't really have a definite value, because even if x and y are different, 0 times x plus 0 times y is still 0. Right? So there is no definitive value. But if you do make x and y equal to 1, it would work out just the same. Alright, so we see that when we have 2, 0, 0, 2 is really 2 times the identity matrix and the eigenvalue and eigenvector of any number times the identity matrix will result in give you the same result. 0x plus 0y equals 0. Alright? So from what we did so far, we can see that. Now, in our upcoming videos, we look at other situations. So I'll see you in the next video.